Problem 91. One car is traveling north at 65 miles per hour and it left at 325. A second car left at 340 and has been traveling at 75 miles per hour. And we want to know at 4 o'clock how fast is the distance between those two cars increasing. So let's label the three sides of this triangle. And the first thing we notice is this is a right triangle. So we have a relation. You can use the Pythagorean theorem, write x squared plus y squared equals z squared. Now we can plug in the values that we know, although it may take a little work to find these. To figure out how far this distance x is, we know the car has been traveling at 75 miles per hour, and it's been traveling for 20 minutes. However, these units don't match right. This is hours and this is minutes, so we can trade this 20 minutes in for 1/3 of an hour. So 1/3 of an hour times 75 miles per hour gives us 25 miles. So that's our x. Y we can get in a similar manner. This car has been traveling at 60 miles per hour for 35 minutes. Although we want to change this to hours, so we'll divide this by 12, divide this by 60, so this is 7/12 of an hour. Multiplying these together gives us that the car has been traveling 35 miles. Now that we know x and y, we can plug them into the formula we've been building. So this says 25 squared plus 35 squared equals z squared. We can now combine these together. So this is 1850 equals z squared. So then z is 5 radical 74. I mean, technically we need a plus or minus in here, but this distance can't be negative. So we have z is 5 radical 74. Now that we figured out the missing side, let's go and figure out the missing rates. So we know that z, 5 radical 74. We also want to say something about dx dt, dy dt, and dz dt. dx dt is how quickly the length of x is increasing, and it's been going at 75 miles per hour. So that's the rate of change of x with respect to time. dy dt is how fast this leg of the triangle is changing, and that's changing at 60 miles per hour. dz dt is the unknown rate that we're looking for. So let's now take the same relation we had before, x squared plus y squared equals z squared, and we'll now differentiate this with respect to t. The reason we're using t here is because all of our derivative information is about time. All of our derivatives are with respect to time. So this will now give us 2x dx dt plus 2y dy dt equals 2z dz dt. We can now plug in what we know into this formula. So x is 25. We'd found that here. dx dt is 75. Y is 35 miles. dy dt is 60 miles per hour. Z is 5 radical 74. dz dt is unknown. So now we can evaluate all of this, divide both sides by 2 times 5 radical 74, and we get 795 over the square root of 74 equals dz dt. So estimating this to get a decimal, dz dt is approximately 92.4 miles per hour.